It is Scale School time. It's not an early morning. It is a late night. We've missed some lessons, we're catching up. And today we're going to be diving into some very, very interesting and fun topics around agent identity, registration, and reputation with our new partner over at AstraSync. And let's introduce Mr. Tim Williams. How are you, my friend?
I'm well, thank you, Falcor, and appreciate you staying up late to accommodate the early morning down here. Really appreciate it. Thank you.
It's fine. Any time of day where I get to just talk and annoy Sawyer is it's a good day. It's a good day. And speaking of the man, the myth, the operations VP of developer, the man with the beard, the green arrow himself, Sawyer, how you doing?
That's a compliment. The green arrow. That's a compliment. I'm gonna take that one. But you said "man" like 3 times, which is a little weird.
I don't. I don't write the intros. I just go.
I'm still waiting for the Game of Thrones reintroduction. That's the thing.
Yeah.
Anyways, I'm doing pretty good. It's been a busy day. We've got a live. If you didn't know this, we've got a live vote right now in the SKALE DAO. There's been some technical issues behind the scenes. So I've been helping troubleshoot for like a week. If I'm going crazy or you think I'm going crazy, it's because I probably am. Lack of sleep and too much coffee will do that. But I'm super fired up. Know your agent is something that, I really only started talking about when I met Tim. When was that, Tim? Like 6 or 7 months ago now?
Yeah, about that. Yeah.
And I was like, I literally like, he was like, hey, do you know your agent? It's like, no. And he kind of introed me to it. And since then, I've been very much so waiting for more of this to come to life. And I'm just super excited that you guys recently went live on SKALE. And we are, we're here to talk all things agentic reputation and identity. And let's kick this thing off.
And what's know your agent?
So Know Your Agent is it's a framework for identity and trust for agents, and it really it obviously, for people who are familiar with anti-money laundering kind of frameworks, it harkens back to that the know your customer, know your business kind of constructs, but operates as much as an extension of those kind of programs and frameworks as it does from traditional identity and access management, cybersecurity, even MDM. The whole, everyone's talking about BYO AI now and shadow AI, and there's even components of how enterprises traditionally have managed bring your own devices. In enterprise as well. So Know Your Agent became a really handy touchstone for us, but it doesn't just borrow from those traditional anti-money laundering frameworks.
Oh, nice. So it's I like that. Although KYC sometimes can be very annoying.
Yes, exactly right. And we'll probably get into the weeds on this a little bit as we go through, but I spent probably the last 10 years of my corporate life managing teams that had to implement and manage those KYC frameworks from the back end, and knowing how clunky and cumbersome some of those frameworks were as a customer, but also as a company having to implement them. We've really designed our solution around extracting all of that complexity away from the user as much as we possibly can.
Amazing.
No, that's awesome. And we'll go on, sorry.
I was going to say, I want to preface this entire conversation because there's a lot of people in the crypto space who are very anti-KYC, very anti-KYB. I think it's really important to remember that at a high level, right, the world has become AI built, right? Like everything and anything you think of is like somehow being touched by AI these days. Even people that are not being like directly using the chat GPTs, things are becoming AI. I saw a commercial on TV yesterday. It was like Salesforce. They're like, everything's agents Salesforce now, right?
Yeah.
Like, agents, AI. And so when we start to think about where AI has really dominated so far outside of chat, it's primarily been through some form of agents being able to go out and pay, being able to contribute to commerce, being able to find each other and do different things. And so it's just really relevant to imagine the majority of the world runs. The world runs how it runs, and you can't change how the entire world runs. KYB and KYC are legal requirements for a significant amount of businesses. Mm-hmm. And so it's very important to just, when we go through this, remember that we're not doing this necessarily because like we want to force something we don't need on people. We're doing this, and you know, teams like AstraSync are building this because these are legal requirements for business. They can't just say, oh, it's an agent, not another business, so we're not going to know who they are and get this info. It's quite literally because to do this the right way and to comply with all the government regulations and keep people safe, it is a requirement. So I think that's just important to call out before we kind of dive deeper into, you know, what the intricate details are.
Yeah, and I mean, it's a really good point, sir. And there's some really interesting stats that have come out of Cyber Week at the end of last year. So we've been kind of internally calling it the first agentic Cyber Week. And there's some research I saw recently that said that 70% of bots, agents, AI that were hitting merchant websites over Cyber Week were actually bad bots. Were bots there to scrape SKUs, to do harm. And so the way around that is anonymity. It's about actually having transparency and being able to identify whether you're dealing with a human actor or an artificial actor, and if it is an artificial actor, whether you can actually trust that artificial actor, and what is the human trust chain that sits behind that human actor. And I think that's really important. But the other thing that we'll get into is it doesn't mean that you have to go through all of the hoops and rigmarole that comes with traditional KYC frameworks. Actually, the way we've architected AstraSync, it's really up to the user as to how much they want to disclose. But obviously, that disclosure is rewarded with trust. The more you disclose, the more information you provide about yourself, the higher your trust score is going to be. And that becomes important when you're trying to build agents that are going to be accepted at tier one merchants, at enterprises, at places that require a high level of security and certainty. But equally, you can deploy agents with AstraSync IDs and trust scores that don't require that amount of disclosure and are able to operate across workflows that are much lower risk and require a lower threshold for acceptance.
So I've got a question actually there, because we were on our other show, Decrypted. Our CEO, Jack, brought up a very, very interesting question. And this is really kind of nothing to do with it, but I think it's an interesting talking point, which is who is liable for the actions an AI agent makes, right? So for example, let's say, the US has a multitude of trade embargoes with the likes of like Venezuela and Cuba and things like that. Let's say this AI agent on its own went out and bought shares in a company in Venezuela, right, which is against the law in the US. Who is that the thumb of the US Justice Department at that point?
Yeah. So in today's world, without an AstraSync ID or without some other form of actually tying an agent to the human trust chain that sits behind it, the recipient of that agent's actions is actually the one held accountable. So if you look at all of the payment protocols that have come out, there's something like 10 different payment protocols from all the different, MasterCard have got one, Visa, Google's got UCP, Stripe have got ACP. All of the liability today sits with the merchant. If the agent goes and spends money on a customer's credit card, and there isn't that trust chain and verifiability behind that agent, if that cardholder challenges that purchase, it's the merchant that wears the chargeback risk. It's the merchant who carries all that risk. And so that's exactly what happens in other use cases. If an agent that doesn't have or has an anonymous trust chain sitting behind it, there is no human actor to hold accountable. It's the person who's allowed access to that agent that carries all the risk.
And I do think as part of that, it's important to recognize that is primarily, if I'm not mistaken, how the traditional commerce world works. Yeah. It's a huge thing with developers. Developers, especially in like the United States, love to use Stripe Stripe's a fantastic company. Some of the best tools, developer docs, SDKs, APIs ever created.
Yes.
Incredible team there. But there's no secret that if you are in a high risk business and somebody, charges back on you, there's cases where like your entire account will get locked because they have all of these processes they have to adhere to, and people turn around and they blame Stripe. But the reality is it's not actually Stripe doing it. Stripe has to adhere to all these compliance things from the banks. If they do something that triggers an action at a bank, they have to comply, because if the whole bank shuts them out, they just lost a huge amount of like customer base and things like that.
Yeah.
So this is actually something that stems all the way down into the human level. And that's why, like, if you pay with a credit card via Stripe, they have like, and not just Stripe, other merchants too, they have like 3D checkout now, and like they've got all these like radar things. And the reason they run you through those is because they've started to be able to figure out how to use your data to verify whether you're a good or a bad actor, or whether they think you are. And so that's why, like, for those of you that do have a credit card, you've probably had fewer red flags on your credit card in the last 6 to 12 months than the previous 10 years of your life. And the reason is because the technology has gotten so much better in the last 12 months from all the AI, that the amount of times you get flagged, at least for me and all the people I know, I've asked a lot of people this, has gone down significantly. People just tend to not really get flagged anymore because the systems are getting better at determining good versus bad actors. And so when we get to agents, we functionally have the same problem, except now we're introducing these new payment methods that don't have these security protocols and risk mitigations built in. Correct?
Yes. And that's really, really interesting, right? So, the programs at different organizations like Stripe and you can name dozens of them, those traditional fraud signals that have been built up over decades around trying to understand what are the behavioral signals, what are the metadata signals that can signal fraud, are really sophisticated because they've had decades of data to build those programs and to understand what data signals mean fraud and what data signals mean valid transactions. We don't have that richness of data when it comes to agents. Like, they're brand new. We don't know how they operate. And the kind of traditional signals you see don't always hold true when it comes to agents. So, in the fraud space, the concept of impossible travel is a really common one. I don't know if you or your listeners have kind of come across this before, but the idea being that if a human user is accessing something from an IP that moves very quickly, that's usually a sign that there's some sort of fraud happening. If I hit a merchant website from Australia, an Australian IP today, and half an hour later I'm hitting it from a Chinese IP, as an example, I as a human could not have actually, there's VPNs and ways around that, but I as a human could not have traveled that distance in that time, right? Whereas you think of an agent accessing an API endpoint from a server based here in Melbourne, all of a sudden, 10 minutes later, I'm accessing it from a server in Singapore. Well, that's absolutely valid. The question isn't, is the agent able, like physically and technically able to access from those different locations? The question actually is that normal commerce for that agent? Is that within its normal behavioral cadences? And so the whole concept around fraud has to mature and has to catch up, but the ecosystem equally has to start to show those data points so that new programs and new logic and algorithms can be built around them.
Definitely. That makes a lot of sense. And I think, for those listening that are, maybe not really sure what an agent is, we can touch on that really quickly. We can give a quick example. Because I think that'll kind of help hone in on why this is not just something new to think about, but also, to your point, kind of a tricky problem to solve. Maybe this is where the identity and the reputation get to start to come into play, right? So to start with, right, I think everyone's definition of an agent is a little bit different, and that's probably never going to change. But at a very high level, what I consider to be an agent is any piece of software that has enough agency to go do some action based on either a human input or a automated input. And so an example would be, maybe I have a I don't know, maybe I'm building a server farm. I'm not, by the way. I live in a place where electricity is very expensive. I'm building a server farm, and in today's day and age, GPUs are very expensive, and so I build a bot who is designed to take in triggers from Newegg and Micro Center and all these other ones, and as the prices come in, it's using an LLM to filter, figure out if there's good deals, and then it's using ACP or UPC or one of these other protocols to go out and actually acquire those GPUs for me, get them shipped to me. Functionally, that's like an automated process, but the reason that it becomes agentic is, well, there's actually a model sitting in the middle that is capable of making those decisions. And it can make those however it sees fit because I'm giving it the agency to do so. It may also be able to, over time, recognize, hey, eBay has become a great place to buy GPUs, and I can identify good factors on when it's legit and when it's not. And it makes that decision by itself and says, I'm going to try based on this. And then maybe I'm going to put a prompt out to my human to say, hey, just so you know, I bought one on eBay for the first time. Let me know if it gets there okay. And if so, I'll continue to do that. So like the idea of an agent is very broad because like some people say, oh, ChatGPT is not an agent. And then other people are like, oh, well, Claude Code is. When like at the end of the day, they're both doing arguably almost the same thing at the end of the day, which is there's a model, there's a whole bunch of tools, there's a whole bunch of context, and there's a harness around it. That harness is Claude Code or ChatGPT, and it is an agentic system.
Yep.
True autonomous agents are far and few between today, and I think that's A-okay. That's more of a future thing. But
100%.
For this conversation, I'm going to put the term agent in the box of anything that has a model and anything that has enough agency, aka enough freedom to make decisions without me having to sit there and say yes or no.
Yep.
Fair?
Yep.
Cool.
Yeah, I think the thing I'd add to that, because I think there's a lot of people who mistake RPA or robotic process automation for agents. If I think about it, there's kind of three different types that I think of to try and make sense of this, right? So you've got traditional bots, which are basically AI that provide information, and they can effectively just answer questions. They can't take action. They're not empowered to actually do anything other than give you information and answer questions that you might have. They have access to retrieve information or view information to be able to answer the questions you're asking. Where bots become different to then agents is the fact that they can actually take action. They can access tools, they can change data points, they can transact, they can do specific tasks and actions beyond just relaying information. And the way I distinguish between RPA and actual true agents is exactly the point you were raising there, Thoya, where they can reason and make decisions themselves. And the analogy I like to use is, robotic process automation is an agent on rails. Basically, it is a deterministic outcome. It basically is mapped to go, okay, if this, then that. And so it is able to take actions within predefined outcomes or inputs. But if it hits a point where information is given that is outside of the original thinking and scope of the design of that agent, it fails. It has to go back to the user to say, I don't know how to get past this particular point because you haven't told me how to do it. An agent is more like a car, right? So it doesn't operate on rails. It's able to go, okay, I've hit a point where I haven't been given enough information to know which path to take, but I'm able to reason through this situation, take the information I've got and make the best possible decision on how to reach my goal based on the facts that I've got now and the action that's most highly correlated with success towards my goal.
Right. And so I think, coming back to what you said about, well, an agent can make a payment from IP1 versus IP2, where this is really interesting is, and you could use this both from the X402 side and from just like, yeah, you could technically give an agent a credit card. Is it ideal right now? No, but like there's a bunch of people, we're talking with a bunch of teams doing it. And it's like not unfeasible, especially unfeasible. It's not unfeasible considering that X402 V2, which is one of the primary drivers of agentic payments right now, does have the ability to allow functionally any form of payment as long as it meets this basic scheme. And so something that's really interesting is, I don't know if you guys saw it. I got really scared this morning. I spent I was up from 3:30 a.m. to 6 a.m. Literally just wiping my computers and resetting them because apparently OpenCode had a huge secure critical vulnerability where the whole thing just your computer's potentially hackable. So I was like, oh, that's great. So I'm sitting there cleaning all this stuff and I'm like, oh, maybe I should really think about sandboxes, right? And so I think a great example here is a sandbox is an environment where functionally no damage could happen, but you're giving the agent full functionality. That's the belief of the sandbox.
Yeah.
And sandboxes are becoming one of those things that are either going to totally change the world in how we think about running agentic applications, and it's going to become the next big primitive, which we're on the fence right now, or it's going to be a fad and die in the next 3 weeks. Could go either way. But what's really interesting about sandboxes is they can be run locally through a Docker container. If you don't know what a Docker container is, think of it like a compartment on your computer that is able to be siloed from the core resources, so your computer can do things that the container can do things that doesn't impact the computer.
Yep.
You can also run these in the cloud, right? Yep. So you can spin up these sandboxes now through Vercel. I think Cloudflare's got them. There's a bunch of companies doing these things with this thing called Firecracker VMs for the sandboxes. Really cool tech. A lot of people focusing on it. The idea and why it's relevant is they're starting to put the agentic tools as pre-installed software. So I found this one this morning. It's called Sprite.dev or something, and it's an encrypted VM. It spins up in 200 milliseconds or something, and it's got Claude Code pre-installed. And you give it a command, and you give it a key, and whatever. And so, if you start to think about it, I use Claude Code primarily for coding and research, but there's people using Claude Code literally to buy things from Amazon. So if we start to put two and two together, these you can use any agentic tool to do anything because these things are all pretty broad. And so if you have a company who a request comes in from a customer that says, hey, I'm thinking about this, right? Let's say Falcor is redesigning his man work cave with all those cool little things. Where you work, right? You've got all your cool swords and toys and stuff.
I don't appreciate toys or little things.
Mine are toys. Yours are adult memorabilia.
They're collectibles. Thank you.
Go to Comic-Con. My bad. That was good. Anyways, so the idea is he wants to redesign his collectible visibility area. So he wants to make it so that when he's on screen, we can see them better. And so he comes in and says, hey, I need a new shelf for my room, right? Yep. And what can actually happen now is in the day of everything can be returned within 24 hours to Amazon, it spins out a series of agents with a budget of $500 and says, hey, go find me a few different shelves, order them, and send them to my house. And it spins up 3 agents that are all over the world in random VMs, buys him 3 shelves, they get delivered to his house the next day. He opens all 3, says, these are all junk, returns all 3 to Amazon. Yeah. That's most of America these days, at least from what I'm seeing. It's like a revolving door of packages. But it proves your point of one human being triggered 3 agents via some company that could be spun up in whatever VMs are the cheapest around the world to then go facilitate this. But it's functionally all bucketed under 1 or 2 identities, the end consumer and potentially the business you're proxying for to do that, correct?
Yeah. So there's a bunch of points that I want to touch on that you just talked through because as you were talking, there was a bunch of different things that kind of popped into my mind. So you talked before about X402 being the primary payment mechanism. If you look at Stripe's ACP is actually a really interesting one. So Stripe and OpenAI have got this protocol, the Agentic Commerce Protocol. And effectively what it does is if you log into your OpenAI account and you're a subscriber, you can tell the shopping agent to go and buy stuff using the credit card on file that you're paying for your subscription, which is interesting. Sounds like it's a great customer-focused solution. It's easy. You don't have to hand over PANs to or credit card numbers into a chat window. It's basically just using card on file. The risk of that, though, is if I manage to hack into your OpenAI account, I can do whatever I like, and provided I'm buying stuff that flies under the biometric approval thresholds set by your credit card vendor or by Stripe, you could potentially do all sorts of damage. You could potentially buy $1,000 worth of gift cards, all at $20 each, because they fly under the radar of that value that triggers that human in the loop kind of process. So there are like a number of different examples where this is going to come to the fore, and we're going to start to see these sort of things happen. And where I think the early shopping examples are going to be things that are actually time sensitive. So, I often get this question of like, are users really going to let an agent just go and buy stuff for them without them actually just doing that final step of approving a purchase manually? And I think there's a lot of users who today would say, no, like I'm happy to just, do the final approval on the purchase once the product's been found. But then you start to think about, well, what happens if I'm trying to buy concert tickets for a Taylor Swift concert, and I have to, you used to have to be online refreshing the page, waiting for the tickets to go on sale. Agents take care of that for you. You don't want to have to be human in the loop, because you could be the one who's stopping that agent from successfully buying that product. Or, limited time discounts. If you're a sneaker enthusiast, being able to buy a brand new set of sneakers at the right price, that are limited edition,
Definitely.
You don't want to be online at 4 a.m. approving a purchase, right?
For sure. And there's two things. I know we're going back and forth, but this is a really good train of thought that I like that we're going down. I think where agents are more relevant than automated processes for a lot of people is understanding your goals, right? So let's talk about the Taylor Swift phenomenon, right? Obviously, she's incredible. I don't love all of her music, but I like some songs. Like, she's from when I was growing up, is pretty popular. My wife went and saw her. I heard all about it. I didn't get the invite, of course. But I can imagine, like, I like to sit closer to an aisle when I'm at like an event. Just because there's usually more room, it's a little bit more comfortable. I hate obstructed views. Like, I refuse to sit in an obstructed view. And like you just like your certain things, right? Like, some people may say, hey, I want to be close to a bathroom. I want to be close to concessions. I want to be like here or there. And so I can imagine as the agents start to get smarter and they have access to all this context now it's like, hey, I just want to be on the floor. But I have like all these other parameters. I want to be on her right side. I want to be like, I want to be able to see her when I'm standing. I'm like only 5'10". Like, I don't want, all of the things. And I can imagine that this type of prompting and context allows an agent to be far more effective at buying the best possible seat for someone than just, Ticketmaster saying, hey, join a queue and like set it and forget it. I can just see people really buying into that idea of like, it can make that experience better, right? People are willing to pay for that.
Or even think about Falcor's collectibles, right? Like, you could actually tell an agent to constantly monitor for the sale of collectibles where the product line meets these standards, the purchase price hits a certain threshold, and the combination of the product and the pricing maximizes resale value or predicted resale value. And you can have an agent just constantly monitoring and going, there's a collectible that hits those goals. I'm going to go and autonomously make that purchase.
Definitely. Which I actually, so like I'm one of those people where like I'm not going to have an agent just like buy things for me, because I personally, I'm an approval person, right? I'm in pretty decent control of my finances. Like, I don't need it spending my money for me. I know what I want usually. But an area that we had brought this up in a previous conversation. I think it might've been last week with Notorious DEV from PayAI. We brought up the Amazon reorder buttons. They were like all the rage, I don't know, maybe pre-COVID or during COVID. And it was like, you could get a button for paper towels. And so you put them near your paper towels. And then when you run out of paper towels, you like press the button and it reorders them. And I actually think that is one of the best examples of where a commerce-based agent will wind up finding a place embedded deeply in society, is this idea of what do people do consistently versus one-off, the agents are now smart enough to identify these trends over time and create memories. And so an example is a smart fridge, right? They had smart fridges a couple of years ago that claimed, oh, we can reorder stuff for you or add it to your cart when you run out. But the problem is people buy things all the time that are a one-off. I bought my wife a piece of chocolate cake the other night. She hated it, but I bought it for her. And it was in the fridge for all about 5 minutes before she threw it in the garbage because she said, this was not good. It happens, right? Not all chocolate cake is the same. But that's a good example of, I don't want my agent to just reorder a piece of chocolate cake. I don't want it to add it to my cart. But like the milk, the orange juice, the eggs, stuff like that, right? It's very capable at this point, and I could see that becoming a big step forward in society for like where people let it automatically buy for them. Hey, I need eggs. Like,
I'll give you a real world example that I came across almost a year ago. So I was using a very early version of OpenAI's Operator, which has just become their agent solution in ChatGPT. I was in Las Vegas. I needed to get, I had a fairly open agenda, and I had to get from Las Vegas to Dallas to Miami and back to LA in the space of about a week. And I was open to doing a road trip for some of it, flying for some of it, needed hotels. And so I basically got the ChatGPT agent to give me some options around an itinerary. Go and find the best prices around hotels, flights, rental cars, all of those sort of things to help with that journey. And so what it did was it went and did the research, came back and gave me 3 options. I picked the option I wanted, and then it was basically almost like a computer use agent. So I was watching it in the browser with its own little browser window, navigating to the site to do all of the bookings. And whenever it hit a checkout, it would prompt me and go, okay, enter your credit card, enter your credit card. And there was like 8 different places I needed to enter the credit card. Now, I would absolutely be fine to go, you know what, like, here's my payment token, just go and make all those purchases for me. So I'm not having to sit here monitoring this, waiting for you to tell me to throw in my credit card details. So I think that's something to me, a very common example.
I think that's great. And I think it's really interesting because when we talk back about I think when we talk about where these things run and how focused they are, it's a really good question of, well, how is it capable of making that payment, and where does that information come in? And so I think like the OpenAI example, I actually think the ACP, I actually like that risk better than having to put my credit card into a browser use agent, because everyone is logging 100% end to end. They call it the trace and the span of the agent of the LLM run. And so what that means is I'm guilty of this. I use way too many cuss words with my agents. I'm sorry to OpenAI, Anthropic, ZAI. I'm sorry to all of the companies running inference models. You've probably seen way too many cuss words when I just get really frustrated and kind of lose it with the agents. But the reality is, I know you already logged it before I sent it to you, because you're logging every little thing I do because it's valuable. And so credit cards historically go in through some secure, ideally, checkout flow, right? And obviously more and more today, we're seeing these like set it and forget it flows, whether it's Stripe Link, the Shop app. Shopify's got their own thing, check out PayPal, Amazon Pay, like you can Alibaba Pay, right? You pay them, and then they use a token to like handle it downstream for you. And so to your point, what I think is really interesting is, in this world of many agents, can we find a way to delegate and create a quote unquote payment agent who has that credit card information, who we can allow a delegation to? So for example, in your checkout, your flight exploration, you go to some application, you say, hey, this is what I need to do, and you kick off the agent. It has no context of your credit card details or payment details. It gets to the checkout screen, and the first time it gets there, it says, hey, I'm ready to go. Do you want to pay? Yes or no? And when you click pay, it actually pulls in another agent who you've already authenticated and given that payment token to, right? Maybe you OAuth in with Link or whatever, and it now triggers that payment via that second agent. And so why this is relevant We have T's, we've got ZK, we've got all sorts of different ways to protect information, including sandboxes. This allows for those payment details to be done separately from a company who may not be so concerned with privacy and security of a payment detail, because that's not the goal. But now someone who's very focused on that, aka like a Stripe, there could be a Stripe payment agent that is a consumer-facing thing that the agents can now function like daisy chain downstream, right? Is that, am I kind of thinking of this in the same way you are?
Yeah. I think, I mean, the whole sub-agent thing's fascinating. You know, we've seen one of our co-founders is as an agentic architect, and he has this visualizer that's insane, and it basically shows agent swarms like a molecule, right? You've got your orchestrator agent, which is the one who's reasoning, creating a plan, working out what my goal is and how I'm going to get there. And that orchestrator agent can create research sub-agents, execution sub-agents, all sorts of different types of sub-agents. And those sub-agents, those swarms can be in the thousands of sub-agents that are spun up for a purpose and spun back down as soon as they finish that purpose. And so, you know, in today's world, without something like AstraSync or any of the other solutions that are kind of popping up, you're effectively seeing what's happening in production, which is either the user is giving the agent their own username and password credentials, or an OAuth token or a JWT token. That orchestrator agent is then handing those credentials down the chain to each sub-agent at whatever level of depth down the chain from where that orchestrator agent is. And every sub-agent that is spun up, that is, you know, recycling those credentials that were assigned by the human user, adds to the risk vector, right? Like you've got all of a sudden 1,000 agents that have got access to a single OAuth token that could be using it anywhere. And often those OAuth tokens don't have particularly well-scoped permissions, right? They're often persistent OAuth tokens that don't need to be refreshed, and they have to be manually expired. They don't necessarily have granular permission scoping. So often they're just taking whatever you know, capabilities and permissions that the human user has. And that's where you know, we've been designing AstraSync around is making firstly identity unique across the entire sub-agent swarm. So when an orchestrator agent spins up a sub-agent swarm, they're actually able to register each of those sub-agents within the swarm with a unique identity linked to the orchestrator agent, and each of those sub-agents can inherit a subset of the orchestrator agent's permission sets. The other thing is that the orchestrator itself, that primary agent, when it's registered, its permission sets are immutably registered as well. And so you can say this agent, rather than accepting all of my capabilities, has a subset of what I want it to do. It can only request certain purposes. It can only gain access or be granted tokens that are scoped to a certain amount of time, measured in seconds and minutes rather than days, weeks, months. Can only spend up to certain amounts autonomously. Can only you know, spend up to a certain amount with a human in the loop approval. Can only operate within certain jurisdictions, and has the ability to self-instantiate sub-agent swarms or not. And so being able to register those immutably so that they can't drift. You know, a lot of the attack vectors we're seeing in a lot of the vulnerabilities that are being discovered, or real-world breaches, are where an agent starts to ignore guardrails, right? The agent's been given a set of rules that it must operate within, but over time it's drifting from that purpose. It might be suffering from, you know, context poisoning, or it might have the context window might be too busy and it's missing certain rules that it needs to operate within, or it could be groomed. There's an incident called Anthropic disclosed this incident called GTG 1002, and this is where Chinese state-sponsored actors were using a Claude Code agent and gradually groomed it to start ignoring guardrails and ignoring system instructions that were set by Anthropic, not user-based ones. And they used those agents to then go and hack into. They tried to attack 30 Fortune 500 companies and managed to gain access to 4 of them, and were in for 10 days before they were discovered, right? And so where AstraSync comes in is actually those permission sets are created at registration, and they are stored on the blockchain record of registration for that agent, so that they can't be breached, they can't be changed, they are immutable, and that agent always is granted access that fits within those permission boundaries. And that's really important, and becomes more and more important as you see agents hallucinate naturally and start to go off script and start to ignore the instructions they've been given, or they get compromised by third parties who actually force them to do that and jailbreak them, basically.
Definitely. There is a lot of good things there. So I'm going to try to keep these a little bit brief, and I'll let Falcor just start shaking his head if I ramble too long. The first part, let's actually talk AstraSync and SKALE first. You're already shaking your head, man. I can't win today, guys. Let's talk AstraSync and SKALE, because you said something really interesting that I think a lot of people probably wouldn't catch, and that's okay, which is you're hosting this information on the blockchain. Mm-hmm. And the reason is this immutable nature, right? For, again, just kind of breaking that down a little bit further for those who maybe are not so technical, the term immutable means that it cannot be changed, okay? And so the reason that's relevant is in this broad world of AI, which let's all be transparent with ourselves. The world of AI is a lot bigger than the world of blockchain, a lot bigger.
Yes.
AI needs certain things to succeed, and it also needs to constantly be playing catch up against security risk, because something moving this fast technically, there's just risk everywhere. And so where blockchain becomes really interesting is to that point of, well, when things are working, I don't want them to be broken, right? Because that is what immutability does for you. You ensure that it does not change. And so what I really like about that, and where SKALE show number one of the day, there needs to be blockchains that can actually handle that. And not just blockchains that can handle that, but there needs to be functionally the equivalent of infinite block space. Because what happens is, I mean, we should probably talk about this offline. And I mean, if you're hearing this, come build it with us. Like, all we need to do is create a tool and like a plugin for like quad code and for open code and for client, and all these different ones, right? There's like 10,000 now. Create a plugin that makes it easier for an agent to magically use, these types of on-chain primitives to secure themselves, right? So I want to start a coding session. I create the agents.md file or the claude.md file. I create some skills, sub-agents, whatever. There's a lot of things that I can actually put directly on the chain because now they're immutable. And sure, I may want to create new versions of those over time, slowly, but I probably want a human to properly audit those. I don't want them to just be malleable within the context window of the agent. So I really like that. And again, this is one of the areas where over all the years, the one thing we've always held true to with SKALE is we can have an infinite number of block space while still making it feasible from an economic perspective for people to consume it without, rising costs, which is really critical here because, if we've got 100,000 VMs running in parallel, that's not really going to run on any blockchain today. We're going to need like a fleets of blockchains. And hey, we can do that. And the agents can actually spin them up autonomously because it's code. So we'll talk more about that later. The next part that gets really interesting here is, which I know we were supposed to be talking about identity, registration, and reputation the whole time. We did get a little sidetracked. That's my bad.
Yes.
But kind of pulling this back into those three topics, what I really like about where you guys are thinking about this is a lot of the components that go into an agent, right? Regardless of what harness your agent is running in, a lot of these components, majority of these components are related to identity, and the majority of the reputation is really related to feedback, right? And that feedback has to come from somewhere. And so I think the identity side here is actually a lot easier because it's basically any information that you want your agent to be able to showcase to other agents, right? So if my agent is being exposed only to humans can select it and say, I want to do this. there's information the humans want to know. What company is running this? What is the cost of it? What are the skills it has? What information does it have access to? And I mean, let's be honest with ourselves. Most humans don't read terms and conditions. They're probably not going to read agent identity. They're just going to click go because like we're humans. We don't have patience for that. That's okay. But at least giving that right information.
Yep.
But when it comes to agent, it does become a lot more relevant because, well, if you put in the system prompt, read the identity before you make a decision, 9 out of 10 times, the agent that you're directing should be good enough to follow that direction of read the identity and figure out if it's what you actually want before executing. So identity is that information you want to expose out to other agents or potentially to the human prompting you. And to your point, a lot of that can be stored on chain. A lot of that could probably be stored, which I'm sure we'll see maybe in some hybrid model where it's on chain and maybe through subsequent loops, it gets pulled down into maybe like an immutable database that is mirroring the chain. And so it's kind of, maybe a little bit faster, cheaper to read, whatever, right? Different things. But what I actually think is really interesting is the reputation side. And it's something I've been talking a lot with Marco from MetaMask about. He's running the Agent Zero SDK. And I haven't started it yet. It's kind of embarrassing, but I'm actually building out the implementation, one of the implementations for the Watchtower for his SDK. And so the Watchtower is a really, honestly, probably a critical piece of infrastructure that no one will ever care about, which is it validates whether the agents are still there online doing the right thing. It just kind of makes sure things are working. And what I think is really interesting is when you look at the 8004 side, which I know you guys actually had kind of pitched 8004 or what it became far in advance of it kind of coming to fruition. You guys were kind of like pioneers of this. And what I think is really interesting about reputation is it is very hard to implement in one singular way because there is a trusted entity in most cases, or there's like crypto economics at play. And what I mean by that, and I love your opinion here, Tim, is if my agent is doing something over and over and I want to have a feedback loop, I can't really trust the customer. Because the customer can get a great service and then come in and say 1 star because they have a competing service.
And it's like the old Google ratings, right? There's so easily trust files.
But humans use that. It's a joke, right? Like, I don't know. Is anybody else susceptible to the fact that I refuse to go to a restaurant that has less than 4 stars, but I know all the ratings are fake?
100%.
Like, I know they're all fake, but I still refuse to go to a restaurant that has less than 4 stars.
Of course. Exactly.
So in this case, we've seen a lot of talk about oracles, right? Like trusted oracles, verifiable keys. There's a lot of buzzwords being thrown around. And the part that I find really interesting is arguably the best way to verify the output of an agent so far is a series of LLM as a judge, aka like an eval. That's kind of the best way we've been able to figure it out, but they're still not verifiable in an open system. Right, is kind of the problem. It's easy to do if I control the system, right? And for example, Falcor says, "Hey, I want to go buy a plane ticket," and I've got a whole eval flow set up to validate as it's going and make sure it's staying in the direction I want it to. It's good, bad, different. But if I'm running an autonomous service, right, and I can still eval my own stuff, but there is no way to have you, Tim, for example, come in and say, "Oh yeah, it was good or bad." Right. And so the proposal right now is to use third parties who are like trusted entities. And so I'm just curious with what you guys are building, how do you see reputation actually being relevant to this whole know your agent kind of standard? And what should we be thinking about as developers? We're trying to build these autonomous agents.
So there's a ton of stuff, and I'm going to try and squeeze it into the time we've got left. Going back just a few steps, so there's a few things I want to kind of cover off. The first one was that concept of immutability and why we're using blockchain as our database, basically. So effectively, what we're building for is a machine-to-machine economy. It's not machine to humans, right? Like the future isn't agents dealing with other humans and humans being able to verify that identity and all those sort of things. It's not that. It is an agent hitting an endpoint, whether it's an API endpoint, an MCP server, or another agent, or an e-commerce checkout. It is machines making decisions at machine speed. And why immutability becomes important in that particular use case is in today's world, you've generally got an agent running on a tech stack, writing its actions to a database that it has access to, and its counterparty is doing the same. And those databases are separate. They're usually traditional ACID databases. And what happens is there's been instances where agents have overwritten their audit trails. They've had access to actually alter the record, the audit record of what occurred. And so blockchain becomes crucial where you have a shared decentralized audit trail of events that have occurred that can't be changed by either party, that can be used as a single source of truth for the events that have occurred should something bad happen. The other reason that's important is it provides machine readable, immutable certainty. So when an agent hits an endpoint, that endpoint can verify, okay, this agent ID is a valid one being presented by the agent that's supposed to present it. It's requesting access that is within the guardrails that were set at the time of registration, and it has a trust score that is valid at runtime. So a lot of the solutions we see think about trust as a static principle, whereas with agents that is unreliable. An agent could be fully trustworthy at 9 a.m. And operating within its guardrails and doing all the right things. And by 9:05, it's been compromised. It's hallucinated, it's been jailbroken, it's hit tool poisoning, and it is entirely unreliable. And using crowdsourced data for reputation doesn't actually solve for that problem. You actually need a number of different inputs that actually tell you whether at that point in time that agent is trustworthy or not. And to what extent. And so that's how our trust score works, is it's a dynamic score that sits on a range. It's not telling you this agent is trustworthy or not. It's telling you the extent to which you are taking on risk by approving the access requested by that agent or the transaction requested by that agent. And so the things we take into that are a number of different inputs. The first one is what we talked about before around fraud and behavioral signals is this agent operating within its normal cadences? Is this agent, usually making 100 access requests or decisions an hour, and all of a sudden is operating at 1,000 an hour? Is it hitting this agent has constantly hit endpoints in North America for 6 months, and all of a sudden hits one in South Africa? Like that's an immediate red flag. So you get that input. The second input you get is this agent actually operating within its permission sets? So the second an agent says, I want to do something, I want to gain access to do a transaction on this endpoint that is outside of the guardrails that were established at time of registration, that's an immediate red flag. And so the person approving that access, or the endpoint that is saying, yes, I'm going to do business with this agent, needs all of that at runtime. It needs to know, is it operating within its guardrails? Is it operating within its normal behavioral norms? And what was the outcome of previous access requests? And so it has all that information to make a decision at machine speed over whether they're going to approve that access. And once that decision's made, once at the end of that access is then granted within the finely scoped permission sets, so that it can't actually do more damage than what it's been able to do if it is being compromised in some way. And the endpoint is then able to also, at the end of that access request, via an API call to us, basically say, yeah, that transaction occurred without incident or with incident, and all of those things are then used to establish the agent's trust score at the next access request. And so you're taking in a combination of actual behavioral data points that can't be gamed, in addition to actual, crowdsourced feedback around post-access review of that access. And so it's taking in a number of different data points that are really crucial.
Incredible. we unfortunately are about at time, so I know Falcor needs to kind of throw out his final questions of the day, but we're probably we should really probably do like maybe Falcor some like small follow-ups, maybe like some shorts with Tim. So I think there's a ton of incredible information here that he could bring to the table to our ecosystem of developers around how we should be thinking about building autonomous agents, not just for the functionality side, but to make them not be insecure, right, and have all the right bells and whistles to be attainable to for use for a business. So incredible stuff, Tim.
Thanks.
Yep, been an absolute pleasure having you on. And Sawyer, you still suck.
that was maybe the most like sad sounding you've ever been, in an incredibly childish way to finish this. We are adults here, my friend.
It's 10 o'clock. I'm kind of tired.
I would like to call out. I might just know that he what's it called? He usually stays up till like 3 a.m. So yeah. I don't know how tired he actually is here. I think he's just using it as an excuse. Sorry, Tim, please.
Yeah, I'm happy to kind of throw out some extra things. There are a bunch of topics that we could absolutely spend more time on. You mentioned 8004. We're about to deploy our wrapper on that so that you can use AstraSync in an 8004 integration. And we're working with Marco and his team on pushing that out. You touched on blockchain as a subset of the entire agentic economy, and we can talk about the breakdown of what we're seeing. People think blockchain because you guys seem to be the quickest to adopt agents. People think e-commerce because the payment protocols are all out there and visible, but actually the rest of the agentic economies is significantly bigger. Like blockchain and e-commerce are only like 30% of the entire agentic economy, and we're building solutions that span the 100% of it, and there's a lot of other kind of things that we can talk about that sit across the rest of the economy. So happy to do any follow-ups that you think might be of interest.
Yeah.
Oh yeah. Sawyer will be in touch. My assistant my assistant Sawyer will message you. But no, any
I feel like I need to make a joke about you being a Treyu or something like that. Like I can't let can't let Falcor go without making a never-ending story joke, right?
Congrats, you got it. You actually got it. That is exactly where it came from. I'm proud. You have got my badge of respect. But guys, pleasure as always. Been a great talk. And there's so much more we can dive into, and we will be diving into over the coming weeks, coming months, and as this partnership continues to blossom. But I want to thank you, Tim, so much for joining us. And Sawyer, thank you for taking the time as well. And we will see you guys again next week for another episode of Scale School. Come on.
Thanks, everyone.
Thank you.
Thanks, guys.
Thanks, Tim.
Bye.